Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining the second part of the process activities. So in the first part of the process activities, I discussed the first process activity, requirement specification. So suppose if you want to know more about requirement specification, the link for that video is in the description section. In this video, I am discussing the second process activity, that is software design and implementation. As you all know, so while explaining SDLC, I told you that the phases of spiral model or waterfall model, right, starts from requirement specification, next analysis you have to do, next you have to do the design, next implementation, next testing, after that maintenance, right? So in this video, while explaining those activities, right, in detail explanation was not there, right? Just I explained the SDLC model. So here I am explaining the each phase in detail. Especially in this video, I am explaining the software design and implementation in detail, right? So if you are not subscribed to my channel, please subscribe to my channel and don't forget to like and share with your friends, right? So let me begin the second process activity, explanation of second process activity, that is software design and implementation. So this is the diagram for software design and implementation. Here you can see for design, to right, design means what? Design means you are going to convert your requirement into diagram format, right? You are going to convert your requirement into diagram format. Why I am going to convert my requirement to diagram format? Because diagrams are easily understandable compared to the text document, because your requirement is a text document, right? So instead of using the text document, I can convert that output of the text document into design, that is diagrams, right? So this here you can see here there are three steps here in this diagram. Design inputs. So I will take the design inputs. Inputs are nothing but requirements. So I will take that requirements. I will convert that requirement into diagram format, that is right. How I am going to convert that input into output means using design activities. Getting, guys? So here you can see here design inputs. What are the inputs I can give? Especially I told you requirement specification. Requirement specification is the input to the design, because by seeing the requirement specification only, I will convert that requirement into designs, that is diagram. Not only that, platform information also you needed. That means platform information means while designing you have to consider which OS you are using, whether you are using a Unix or a Windows OS, like that. Platform information also needed. It will be easy for you to design, right, based on the platforms also, along with the requirements. Not only that, along with that you need data related information. What type of data you are using for your software, right? So data especially depends on the domain. For banking, the data will be different. For university software, the data will be different, right? So you need all these things along with, right, along with the requirement. You need platform information and data related data also, right? Getting, guys? So I can take this input and I can design. I can develop actual design, that is diagrams. So you can see here the diagrams, architectural design, that is overall architecture. I will explain in detail, right? Don't worry. Interface, I can do the interface design, component design, database design. See, for architecture, overall architecture also will be in the diagrammatic form. Interface also will be in the diagrammatic form. Component also will be in the diagrammatic form. Everything will be in the diagrammatic form only, right? So right, see, the diagrammatic form is what? System architecture. Architectural design means the output is system architecture, that is in the diagrammatic form. Interface design means obviously interface specification, that will be in the diagrammatic form. So component design activity is nothing but you are going to develop a design of a component specification, that will be in the diagrammatic form, right? Getting, guys? So you will take the input, you will convert that requirement input into diagrammatic forms, that is design outputs. So design means diagrams. Design means diagrams. different models, activity diagram, use case diagram, sequence diagram, right? You will know these diagrams in detail in the upcoming videos, right? Getting, guys? So I will explain these steps in detail. See now. So the figure shows the design descriptions that may be produced at various stages of design. Yes, so at various stages what you are going to produce, those details are there in this diagram. See, I will explain this. This diagram suggests that the stages of the design process are sequential. You can see, first I will take the input, I will develop the designs, and I will produce the outputs. Yes, you can see that is sequential, but these phases are interleaved. Interleaved means what? Sorry. So these phases, see, in fact design process activities are interleaved. Interleaved means while doing the architectural design, I can do the interface design also. While collecting the requirement specification, I can do the data description. I can while collecting data description and requirement specification, I can do component design also. It is possible, interleaved. But while designing, if you follow the steps sequentially, it is better, but it's not a rule. These phase activities are interleaved, right? It is possible. You can start from anywhere. Why means, if you are a non-technical user, if you don't have any idea regarding the software engineering, it is better for you to start from design inputs. But if you are a software engineer, right, who is developing the product, for him the small details are not necessary for him. Directly he can start with the design activity. Software engineer, because he has the knowledge, that's why he can skip this first step. He can directly start from the second step because he has the knowledge regarding the design requirement specification, right? That's why I'm telling you that it is interleaved. If you want, you can start from anywhere. Getting, guys? If you have any doubts, please put your doubts in the comment section. See, so this diagram suggests, yes, the steps are sequential. In fact, design process activities are interleaved. Yes, it is possible. And one more important thing, feedback from one stage to the another is inevitable in all design processes. Yes, you can take the output of one phase as the input to the another phase. Yes, it's possible. Yeah, you are doing like that only. Requirement specification output is the input to the design activity. Getting, guys? The second phase output is the input to the third phase, right? Getting? So if you want to make any changes, you can do that. Rework is possible here, right? Rework is possible. Suppose any problem occurs while designing, you can go back and you can change. That is possible here. You can go back and make your changes. Getting, guys? Next, from the figure we can see that, right, the specification for the next stage is the output of each design activity. Yes, I already told you, the specification for the next stage is the output of each design activity, right? You know that, right? Next, this specification may be an abstract formal specification that is produced to clarify the requirements. And one more important thing, whatever the input you are taking for the design, that input, that is specification, that requirement specification is complete, is formal, it's error free. You can't take a error specification document, wrong specification document, and you can't produce a design. No. Whatever the specification you are taking, it is a formal specification. It is not informal. That is produced to clarify the requirements. Getting, guys? So this is formal requirement document. No errors are there here. As the design process continues, this specification becomes more detailed. Obviously, you can add more details once the design process continues. When you add, for example, when you develop a sequence diagram, when you develop a use case diagram, don't worry about those use case and sequence diagrams. You will come to know in upcoming videos. So when you develop those design diagrams using a requirement document, you can add some extra details to your requirement document. It is possible, because while writing the diagrams, you may come across some new ideas. You can add that. You can add the details to your requirement document. Right, as the design process continues, this specification become more detailed. You can add that. and the final results of the process are precise specifications of the algorithms and data structures. Obviously, whatever the design you are going to develop, the diagrams are more precise. That means they have the more details. They are error free, right? While designing, just remember guys, not only you are writing different models, that is use case diagrams, sequence diagrams. Not only that, along with that you have to develop what type of data structure you are using and what type of algorithm you are using. You have to specify that things also in a design process. Not only diagrams, you have to specify algorithms. You know that why I have to specify algorithm? Algorithm is nothing but a step-by-step procedure to write a program, right? So it will be easy for you. If you specify algorithm of your project, definitely it will be easy for you. That's why you will write data flow diagrams, flow charts. Getting guys? Not only that, you have to be more careful while selecting the data structure. For example, you can data structure, array, right, list. So you have to select data structure also, because for one type of application you may use one data structure. For another application you may use another type of data structure. For one application, array may be more suitable. For one application, list may be more suitable. You have to decide that also in design phase. Getting guys? So along with the diagrammatic representations, you have to choose algorithm and also you have to choose data structure. What type of data structure you are going to use while developing the project, while writing the program, because using the design only I have to implement. Using the design only I have to write the program. For writing the program, what is my input? Design is my input. I can easily understand and I can easily write the program. Next, the specific design process. If I say a design process activities, what is the first design process? What is the first design output you can produce? Means that is architectural diagram. Architectural diagram can be the first output of the design process. You can ask a question now. What is architectural design? Architectural design means, in a simple word, it is a overall architecture of your project. By seeing that overall architecture, you can come to know about the components, subcomponents or subsystem and the relationship between the subsystem. So for example, see, so this is the architecture of the project of a face identification. This is the software for face identification. For that face identification software, this is the system architecture. You can see this is the overall system architecture. You can see there. So these are the subcomponents, subsystems, and these arrow marks are nothing but the relationship between one subsystem to other subsystem. Getting guys? You can see this is the overall architecture of the face recognition software. See, input training images, this is one component. Pre-processed training image, that is one component. Apply the algorithm. I told you, along with that diagrams, you need to select the algorithm also. Yes, see, training stage, one step. ID model, one step. Identification step, one subsystem. Apply the algorithm again. One subsystem. See, subsystem and the relationship between the subsystem. So this is the architectural design, the overall architecture of your software product. You have to convert your requirements into this form. See, face recognition can be easily understood now if I see this diagram. Getting guys? Hope you are understanding guys. Next, abstract specification for each subsystem. So here what I did, I developed the overall architecture. This overall architecture is not enough. No. I need some additional details. I need some extra details. I need some in detail approach. I told you, while building a house, blueprint is like nothing but a overall system architecture. But color of the window, color of the door, what tiles you are using, those additional details, right? That is low level design. This system architecture is a high level design. What in detail, if you go inside, that will be a low level design architecture, because you have more details in low level design rather than the high level design. This is a high level design, you have details, but it is very less. I need more details. That's why what I will do means, I will do interface design, component design, abstract specification. How means using sequence and activity diagrams. So many diagrams I can use, and I can collect more details. See, I will explain now. See here, abstract specification for each subsystem. That means abstract specification of its services and the constraints. See, abstract specifications will be like this. Abstract specification means some in detail, each subsystem details. See, compared to this, you have more detailed information here. Getting, guys? My main aim is to gather more detailed information while designing, because I need this detailed information to write a program. Getting, guys? So abstract specification for each subsystem. I need the details of each subsystem, not only the overall architecture. I need the details of all the subsystems. Next, interface design for each subsystem. See, interface means what? Interface means it's a means for communicating. Right, one subsystem can communicate with the other subsystem using an interface. You see, input training subsystem can communicate with the pre-processing training image. The pre-processing training image can communicate with the training stage. So one interface can communicate with the other. One component or one subsystem can communicate with the other subsystem using an interface. You have to design that interface also. Here in this overall architecture, I don't have the details, interface details. But if you go further, if you go in detail, you have to develop that also. Getting, guys? Not only the overall architecture, you have to document the details of each subsystem, and also you have to document the details of interface interface for each subsystem. Getting, guys? Along with that, for each component you have to design. For components, you have to design components. Now you can ask a question, sir, what is the difference between a component and a subsystem? See, guys, component and a subsystem means, for a subsystem, for example, authentication feature, username and password feature. There, to enter the username, you have a text box. To enter the password, you have a text box, right? Getting, guys? Username and password, it is authentication subsystem. What is the component that authentication subsystem contain? It contains text boxes. How many text boxes? 2 text boxes. Getting, guys? Hope you understood the difference between the component and the subsystem. So component is different, subsystem is different. See, for example, see, input test image. Input test image is the subsystem, but this input will be in the form of what? It will be displayed in the screen, right? The screen is the component. Getting, guys? You have to design that components also. For example, while login to your email account, authentication feature, that is username, password you should give, right? That username and password is a subsystem. But how you are going to enter username and password? By using a text boxes. Text box is a component. Not only that, after entering the details in the text box, you will click the submit button. Submit button is the component. So subsystem may contain component. Getting, guys? Understood the difference? Here components may be inside the subsystem. For example, authentication feature, I told you, username and password contains text boxes, right? That text boxes are nothing but components of authentication feature. Getting, guys? So you have to design that components also, radio buttons, check boxes, those things also you have to design along with this. Hope you are understanding, guys. Suppose if you have any doubts, please post your doubts in the comment section. I'm always happy to help you guys. Next, data structure design. I already told you. While designing only diagrams are not enough. You have to design the data structure. What data structure you are using? You may use array or whatever it may be. So next algorithm you have to design also. Getting, guys? So if I say a design, you have to consider all these activities. You have to design overall architecture, you have to design the subsystem, you have to design the interface for each subsystem, you have to design the component within the subsystem, that is inside the subsystem. Not only that, Not only with the architecture, you have to consider the data structure, whatever the data structure you are using, array, array list, and algorithm design. What is the algorithm you are using, you have to design that also. It will be easy for the programmer to design or to write the program. Getting, guys? Next, one more important thing, whatever the design process I explained so far, this converting the requirements into diagram, it can be called as a structured method. It can be called as a structured method. That means you are converting your requirements into different types of models, architectural models. That's why it is a structured method. A structured method includes a design process model. See, models, notations to represent the design, report formats, rules, design guidelines. Getting, guys? In a simple words, I have to tell you that structured method means you are converting your requirements into different models, notations. How you are going to do that means, see, this is on model, this is on notation, this is on model, this is on notation, like that, right? Getting? Now we will explain this. See, next, if I say a model or a notations, you can use the different variety of models for your design. Not only the overall architecture. I told you, overall architecture is high level design, but you need extra details. That's why you have to develop low level design. Low level design means in detail architecture. To develop that in detail architecture, I can use a structured method. That in turn, I can use different models. So first is a object model, right? If I develop an object model, I will, right? It will give extra details. That's all. To gain the details, I have to do all this circus. So an object model. An object model, what it does, that shows the object classes used in the system and the dependencies. Object, you know that object oriented programming. So object oriented programming, you will develop a class. Class is nothing but a collection of objects. Class will be represented as a collection of objects. For example, see here, what are my objects? User is my object, system application is my object, camera is my object, trained neural network is my object. Getting, guys? Using these objects, I will write the sequence diagram. Don't worry about the sequence diagram so far. Don't worry. So far you have to understood what are objects in my project. This is the project. What project we are discussing here? Face authentication, right? Face detection. So user is one component in this. System application is one component. Camera is one component. Image database is one component. See, or object. You can call it as an object. See. So the object model shows these object classes. Next, along with the object classes, sequence model also you need. Why you need a sequence model? A sequence model shows how objects in the system interact when the system is executing. See, so here these are the objects, right? By seeing the sequence diagram, you can understand that how these objects are interacting. See, it will tell how these objects are interacting when the system is executing. See, user object is interacting with the system application object using touch interface. If your user touches the screen, system application will take the input. See, system application, how it is interacting with the camera object. System application object is interacting with the camera object by using the start camera. When a user start the camera, when application start the camera, camera will be accessed. Getting, guys? You can see here interactions I am adding here. In the object diagram, you will just get the details of what are the objects that you are using in the software. But in a sequence diagram, along with objects, you are getting the sequence. Interaction informations also. See, you can see interactions of each objects. Getting, guys? Now we can ask a question, what is the advantage, sir? Object diagram, it has a details, right? But compared to object diagram, your sequence diagram is having more details. That's all. Compared to sequence diagram, the next diagram, state transition diagram, will have more details. Step by step, when you goes on from one model to one model, the details will be increased. The details is going to be increased. Getting, guys? So the third one is what? A state transition model that shows the system states. What are the system states and how the transition means how the movement happened from one state to another state. this will give some additional details compared to your the sequence model. See, this is giving some additional details. The camera how it is interacting. This is the state diagram of a camera, so how it is interacting. But here, see, in this diagram you can just see that camera, you can start the camera and you can see that you can extract the image and store it in a database. You can capture the image and you can store it in a database. Only the details is there. But you want to know, now you have to collect some more details. Now you have to know how this process is going on, how the image is stored in the database. See, camera. So using a camera, you are recording video footage. See, image, you are capturing the image. So after capturing the image, the face is detecting. After detecting, see, face is recognizing. It is matching the faces from the database, right? Your input, you are giving the input to the camera. The output you are going to get, if a match is there in the database, it will. For example, you are comparing two photos, face recognition. If a match is there, face will be recognized. See, if a face is recognized, you are giving a message to the user or a law agency. Why used this means because this is for a face detection of criminals. That's why. So once the match is occurred, you can send a text message to the user. See, this is additional details. So here, compared to this state diagram is having the more details. That's all, guys, right? Don't get confused. You are collecting more details. You are giving more details to the programmer to write the program by capturing all these details. Getting, guys? Next, along with these models, you can use a structural model and a data flow model also. Structural model means system components and their aggregations. Compared to this diagram, the structural model will have more details. Also, lastly, a data flow model. Data flow model means just a flowchart. Your flowchart. You have studied in C programming, right? Data flow model means that is flowchart. Flow from one phase to another phase. That details will be there in the data flow model. Getting, guys? So hope you understood the concepts. If you have any doubts, please post your doubts in the comment section. Thank you for watching the video.